Problems in a solve ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. Write the formula effective resistance between the points A and B. Again, interesting. This is important also. Twice asked in the exam. 12 ohms and 8 ohms are connected in parallel. Hello students, let us now continue our problem session on the chapter electric current. I expect that you have gone through the first session, practiced those problems. You are thorough with that, and which will help us to understand today's session better. The first one. In the given circuit, so a circuit is given below. In the given circuit, I have to calculate the effective resistance. The effective resistance between the points A and B. I have to calculate the current flowing through this circuit, which we call as the main current, and I have to calculate the current through 3 ohm resistor. An interesting problem. So, a circuit is given below, from which I have to first calculate the effective resistance between the points A and B. Circuit na tumba hatradinda analyze ಮಾಡಿ, analyze the circuit closely. This 12 ohms and 8 ohms are connected in parallel. So first, I will find the effective resistance here. 12 ohms and 8 ohms are connected in parallel. So, I call the effective resistance there R1. So, they are connected in parallel. So, R1, R2 divided by R1 plus R2. Formula baride. Problems in a solve ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. Write the formula, substitute, then you solve. So R1 is now equal to 12 into 8 divided by 12 plus 8. 12 into 8 is 96 divided by 20, which is nearly 4.8 ohms. So I have calculated the effective resistance between 12 ohm and 8 ohm, which is connected in parallel. Similarly, if you observe, 4 ohm and 6 ohm are connected in parallel. So again, if you observe, 4 ohms and 6 ohms are connected in parallel. I say R2 is the effective resistance here. So R2 will be now 4 into 6 divided by 4 plus 6. 4 into 6 is 24. 4 plus 6 is 10. 24 by 10, which is 2.4 ohms. So I have calculated the effective resistance between 4 ohm and 6 ohm resistor. Now if you observe, 3 ohms, this combination and 2 ohms, they are in parallel. So 3 ohms, the combination in between and 2 ohms are in parallel. Therefore, now 1 by R3 will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 dash. So that is nothing but 1 by 3 plus 1 by 2 plus the effective combination here, which turns out to be nearly 1 ohm. So I found out the effective resistance between the points A and B. Now I have to find the current through the resistor or current flowing through the circuit. By Ohm's law, I equals V divided by R, where V is 12, R is 1. So this is 12 divided by 1, so which turns out to be 12 amps. So this is the main current which flows through the circuit. And the third part of the question is to calculate the current flowing through the 3 ohm resistor, which you will be simplifying as assignment. The next problem, again interesting. This is important also. Twice asked in the exam. So we will analyze the question given. When 2 resistors, initially the problem reads, when 2 resistors are connected in series, so 2 resistors are connected in series with a cell of EMF 2 volts. This is 2 students, and negligible internal resistance. A current of 2 by 5 amperes flows through it. Very simple. ಎರಡು ರೆಸಿಸ್ಟರ್ಗಳನ್ನ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. and it is connected to a cell of EMF 2 volts. In this case, current flowing in the circuit is 2 divided by 5 ampere. So, when two resistors are connected in series, RS is R1 plus R2. Here in derive martivala, effective resistance in series. RS equals R1 plus R2. Now this RS can also be written as V by I equals R1 plus R2. Ohm's law. V is I into R, or R is V by I, which is R1 plus R2. How much is V? 2 volts. Current 2 by 5 amperes. So 2 divided by 2 by 5 is R1 plus R2, or R1 plus R2 is 5. I call this equation 1. So I have calculated the value of R1 plus R2, which is 5. Now, when the same two resistors are connected in parallel, same two resistors are connected in parallel across the same source, current is 5 by 3 amperes. I have been asked to calculate the individual resistances. Now, so in parallel, we know it is R1, R2 divided by R1 plus R2. Again, RP is V divided by I. Again, R1, R2 divided by R1 plus R2. Again, we substitute 2 divided by 5 by 3. Substitute for R1 plus R2. So here, R1, R2 turns out to be 6. And I call this equation 2. So equation 1, R1 plus R2 is 5. Equation 2, R1, R2 is 6, from which I have to find the value of R1 and R2. Now, by using the equation of biquadratics, I have R1 minus R2 whole square is R1 plus R2 whole square minus 4 R1 R2. This is called equation of biquadratics. This is 5 square minus 4 into 6, 25 minus 24, So R1 minus R2 is 1. Now it is very simple. I have two simultaneous linear equations. So I've got R1 minus R2. R1 plus R2 is 5. R1 minus R2 is 1. So R1 turns out to be 3 ohms. Substitute here. R2 turns out to be 2 ohms. So very easily, just by knowing the expression for effective resistance in series and parallel, forming two simultaneous equations, I have got the value of R1 and R2. Next one. 3 equal resistors. 3 equal resistors. Equal andreno. Here equal means same value of resistance. 3 equal resistors initially are connected in series. ಏನಾಗಿದೆ? 3 resistorಗಳಿವೆ. They have the same value of resistance and they are connected in series across a source of EMF and negligible internal resistance. And these 3 resistors dissipate 10 watts of power. ಅವ್ರು ಏನು ಹೇಳ್ತಿದಾರಂದ್ರೆ, when 3 equal resistors are connected in series, they are dissipating. Dissipate andre kododu anta artha. 10 watts of power. What would the power dissipated be if the resistors are connected in parallel across the same source of EMF? Andre, ade 3 resistors, the same 3 resistors, if they are connected in parallel across the same source, what would be the power dissipated? Which means now I have to relate power and resistance. So we know P equals V square by R. So the basic equation I am using here is P equals V square divided by R. First, the resistors are connected in series. Alva? The 3 resistors are connected in series. So this becomes P equals V square by RS. RS andre the 3 resistors are connected in series, equal value. In series, they dissipate 10 watt power. V square divided by 3R. Why 3R? The three resistors are connected in series. They have the same value of resistance, R plus R plus R. So it is 3R. Next, the same three resistors are connected in parallel. Three equal resistors connected in parallel. So P is V square by RP. P is V square R divided by 3 resistors of same value connected in parallel. Effective resistance is R by N. There are 3 resistors here. So R divided by 3, or P is V square, 3V square by R. P has to be calculated. Divide equation 1 by 2. Do the simplification. It is very simple. When you divide, this turns out to be 90 watts. Notice just comparison. No P is V square by R. For equal resistors in series, 3 into number of resistors. Parallel, resistance divided by N. Substitute, P turns out to be 90 watts. 2 cells. Again from a question paper. 2 cells A and B are connected in series, each having an EMF of 1.5 volts. 2 ಸೆಲ್ಗಳಿದೆ. They are connected in series. They have an EMF 1.5 volts. Therefore, the total EMF, since they are connected in series, 1.5 plus 1.5, this is 3 volts. The internal resistance of the first cell is 0.5 ohm and the second cell is 0.25 ohm respectively. Internal resistance, small r, of the first cell is 0.5 ohm and the second cell is 0.25 ohm respectively. So, small r, total internal resistance 0.5 plus 0.25, which is equal to 0.75 ohm. And the combination is connected across a resistance of 2.25 ohms. Therefore, R becomes 0.75 plus 2.25, which turns out to be 3 ohms. So what is that? First I have to calculate current in this circuit. Again, I equals V by R. V is the total EMF. total resistance. Current is 1 ampere. The potential difference across the terminals of this cell, each cell. So potential difference is E minus I into R. Since it is series combination, current remains the same. Substitute, calculate VA and VB. And the last problem, this is an assignment for you all. I'll just give you the hint. You will have to find the current density and average drift velocity. Current density J is I divided by A, where I is 2 amperes and A is 10 power minus 6. So 2 into 10 power plus 6, direct oral simplification. And drift velocity, I equals NA VD into E. Use this, substitute, you get the value of current. So students, I have worked out few more problems in this session related to electric current. Tomorrow, key problems from the previous papers will be solved. Until then, have a nice time. Thank you.